In this video, we'll be continuing our study of supervised learning, but now we'll be looking at logistic regression, specifically classification. Linear regression, which we've looked at, could essentially predict any number given some inputs. However, this isn't good for all cases. Sometimes we want a model that can predict only a small number of values, so that we can categorize our outputs into something more meaningful than just a number. This is where classification comes in. Classification involves predictions that can only take on one out of a handful of outputs. Linear regression is not good for these cases because linear regression can predict any value, really. So for example, an example of classification is classifying whether an email is spam or not spam. In classification, we bucket this email into either an output of yes, so spam, or no, indicating not a spam email. Binary classification in this case involves two outputs, and we'll call a class a category. In classification, 0 will represent false, and 1 will represent true. True and false in this case aren't necessarily Boolean values, rather 0 will be our negative class and 1 will be our positive class, with 0 indicating an absence of something, while 1 or true indicating a presence of something, specifically an absence or presence of something that we're looking for. So for example, if we have a bunch of data sets involving the tumor size of something, we can classify it into buckets of whether it's malignant or not. So in this case, we can see tumor sizes that have our model has predicted as 1 is yes, so that means they are malignant, while tumor sizes that our model predicts has a value of 0 is not malignant. So the way logistic regression works is that it fits an S-shaped curve to our data set. So something like this, where it kind of curves up and curves back this way. And it also involves a line of division. So basically, data points that are on one side of our line of division will have an output of 1 in this case, while data points on the other side of our line of division will have an output of 0 in this case, so not malignant. Our logistic regression model is based off an actual a mathematic function called a sigmoid or logistic function. And I will introduce this to you for a mathematical understanding of why this works. So we'll call our sigmoid function, in this case, g of z, with z being on our x-axis right over here. And g of z will basically output a number between 0 and 1. As you can see here, this is an asymptote, and this is also an asymptote. So g of z is predicting a value between 0 and 1, in this case, or outputting a value between 0 and 1. More specifically, g of z is represented as this. You might recognize that when z is small, the denominator is big, so g of z is actually close to 0. As in here, when z is very small, g of z is closer to 0. In contrast, when z is large, the denominator is close to 1, so g of z is close to 1. So as z gets infinitely large to the right here, g of z gets closer to 1. And when z is 0, our denominator is 2, so g of z is 1/2, right over here. Okay. So how does this mathematical understanding actually help us with the logistic regression model? So previously we talked about how this represents our linear regression model. In logistic regression, we'll save this value into a variable called z. And as we saw before, z is actually the input of our mathematical sigmoid function. So we'll do the same thing in machine learning. We'll plug this value into our sigmoid function. And once again, we can say that confidently that because the numerator is 1, g of z here will be between 0 and 1. So if we put it all together, we now have this, where this portion of our function is just z. So if we completely simplify it now, we get the following, where I've just substituted this for z. So the input here are features, or a set of features, more specifically, and it outputs a number between 0 and 1, as we previously talked about for logistic regression. More specifically, this function over here outputs the probability that our class is 1, so that something is present. So for example, say x represents tumor size, and y can be either 0, so 0, which means not malignant, or 1, which means malignant. So say our model, logistic regression model, predicts something like 0.7. As I said right here, predicts the probability that the class is 1. So 0.7 means that there's a 70% chance that this data point has a corresponding y value of 1. Or thus a 30% chance that our y value is 0. And tying this all together using proper notation, we'll get this. And all this means is the probability that y is 1 given input x, the vector x, and parameters vector w and b. Okay, in this video we just went over the basics of logistic regression. In the next video we'll go over the decision boundary.